Hey guys, it's Miss Miklos, and today we are learning our final section in Chapter 9, and that is dealing with solving rational equations. And what we're going to be doing today combines some previous topics, but we're going to be looking at it in a brand new way. So let's start with doing some factoring. In fact, it might be a good idea if you guys do these three problems on your own, so press pause, and then come back and we can do them together. So let's look at number 1 here. First thing I look for is, do we have a GCF? And we do not. I also notice that this does not fit a pattern, so I think that we're going to be using opposite of FOIL. I know x and x are the only things that would give me x squared, and I'm thinking plus 5 and plus 2, because if I multiply those, it gives me 10. If I add them, it gives me 7. So this would be our factored form of this polynomial. Number 2, I notice that we actually have a GCF this time, and if I take an x out of both terms, if I take it out of x squared, I'm left with x. If I take it out of 3x, I'm left with 3. I cannot do anything more with x plus 3, so this would be our final answer. Number 3, definitely the toughest one. Our first step, though, for everyone would have been taking the GCF out, which was 3x. And now we really have two different options. The first option, this is what I would probably do. I notice 1 minus 9x squared, I can do more with that. In fact, that fits my difference of squares pattern. So I get 3x times 1 plus 3x times 1 minus 3x. Now, as I mentioned, there is a second way to do this. Some people may have factored out a negative 1 so that we could turn this around to become 1 minus 9x squared. I'm sorry, to turn this around from 1 minus 9x squared to become 9x squared minus 1. This is our difference of squares pattern, so I have 3x plus 1 times 3x minus 1. Both of these answers are equivalent, and if we multiplied them out, it would equal what our original problem was. So factoring is definitely going to be an important part of today. So for our problems today, we have 4 major steps. First is finding the LCD, and we got lots of practice on that last class. The second thing we're doing is going to be very different. Okay? Previously, we have gotten very good at getting an LCD. So that was when we had to figure out what are we missing, what do I need to multiply by. Today, our goal is not to get an LCD. Our goal is to eliminate the fractions. So that's why I'm just going to multiply by the LCD. Next, we are going to solve that equation for x, and it might be a quadratic function, it might be a linear function. We're going to rely on our previous knowledge. And then lastly, we need to check for extraneous solutions. We know that things are extraneous when our denominator is equal to 0, because we know that we can never divide a function by 0 or divide anything by 0. So we're going to be following these 4 steps today. Now, in our notes here, we are taking this a step further because that's how smart we all are. We are going to be examining what is the relationship between this equation and the graph. Now, keep in mind, the very first lesson in this chapter, we graphed very simple rational functions, and that is definitely going to be on our test. The ones that we're doing today will not be on our test, but it's just making some connections in our mind. So if I look at number 1, I know the first thing we need to do is find the LCD, so I'm going to factor each denominator. So I also know this denominator is really 1. So if I'm comparing these 3 denominators, we can say that our LCD is x plus 1 times x minus 1. So what that means is that I'm going to multiply everything in my equation by this LCD. So looking at this equation, I'm saying all of this times our LCD over 1. And the significance of this, it means I'm only multiplying the numerators by this value. Our denominators are all staying the same. And some of you may be a little confused because last class, I always had to multiply the numerator and the denominator by the same thing. And that was because last class we were working with expressions. I know expressions I can only multiply by 1, hence why we had to have the same thing in our fraction. Today, I'm dealing with equations, which means I can multiply by whatever the heck I want as long as I do it to both sides of our equation. So I went ahead and distributed already, and I ended up with this big looking mess. But what I notice is we definitely have some things that are going to cancel each other out. In fact, I think a lot of you guys will probably end up skipping this step and canceling out in your head and writing the next step. Okay, so let's just focus on this first fraction. If we look at that first fraction, I notice these x plus 1s are the same, so I can cancel those out, and I am left with 4x plus 1 times x minus 1. Looking at my next term here, I notice my x plus 1s and my x minus 1s are the same, so I have 12. Looking at our third term, my denominator is just 1, so nothing cancels out, so I have plus 3 times x plus 1 times x minus 1. So what we have successfully done here is eliminate all of our fractions. Now we are going to have to go ahead and solve for x, which by the looks of this means that I'm going to have to do some multiplying. So when I FOIL, I get 4x squared minus 3x minus 1 equals 12 plus 3 times the quantity x squared minus 1. So then I would need to distribute this 3 to both of those terms, and I end up with 3x squared minus 3. So if I'm looking at this equation, what stands out to me is that we have x squareds, which means it's quadratic. We learned last semester we can solve quadratic functions using my favorite, which is factoring. Or if it's not factorable, we could use completing the square or quadratic formula. I'm always going to see if factoring works first. So I'm getting my equation set equal to 0, so I have x squared minus 3x minus 10 equals 0. When I factor this, I need to think what factors of negative 10 add up to negative 3, and I'm thinking negative 5 and positive 2. So I'm going to set both of these equal to 0. So x is equal to positive 5 and x is equal to negative 2. Now, before I know for sure that those are my answers, I need to double check, do either of these make our denominator 0? So let's go ahead and look at that. So let's check 5 first, and I want to point out that I'm not double checking if it makes a true statement. I just want to make sure it doesn't make the denominators equal to 0. So if I put 5 into this denominator, I would get 6. If I put 5 into this one, I would end up getting 24. So neither of those is 0, so I know 5 is a solution. If I substitute in negative 2, I would get negative 1, and I would get 3, so I know that also works. Okay, so all we're checking for, does it cause division by 0? And in this case, neither of those do. So I'm going to make it really obvious that 5 and negative 2 are our two solutions. If we look back at our original equation here, what would have caused division by 0? And there's two numbers that kind of come to mind. I notice if I substituted in negative 1, it would cause 0. If I substituted in 1, it would also cause 0 because of this second denominator. So I'm going to go ahead and write that the values of x that would result in division by 0 are 1 and negative 1. Okay, which we're going to see how that connects to our graph. So if you guys want to graph it in quick graph, that's fine. I'm going to graph it for you guys on my computer and using my graphing calculator so we can go ahead and talk about it. Hey guys, okay, so what I want you to do right now, if you could go ahead and open up your graphing calculator, and we're going to press y equals, I'm already there, and I cleared out everything else. Now you guys may be wondering, how the heck are we going to graph something that is a rational equation? And the way that we're going to have to do that is by getting this equation set equal to 0. So technically there are two different ways we could graph it. We can move everything to the right side of the equation, or we can move everything to the left side of the equation. And I'm going to show my key history here just so you guys can kind of see what I'm doing. I know when I'm putting fractions in, parentheses are really important. So I'm going to go ahead and I'm going to subtract 12 over x squared minus 1 and subtract 3 from both sides so that it is set equal to 0. So my first fraction is going to be the quantity of 4x plus 1 divided by the quantity of x plus 1. Okay, double close my parenthesis because that ended that fraction, minus the quantity, 12, and I don't need to put parentheses around 12 because that's a monomial, divided by the quantity of x squared minus 1, double close my parentheses, minus 3. So if I press zoom 6 here, okay, this is what my graph looks like. And what you guys might notice is that at some points here, so like at 1, yours might be showing you a vertical line here at -1 and at 1. Okay, mine doesn't, but what those vertical lines are, they are the asymptotes. Okay, and we talked about asymptotes. That's something it's getting really close to, but it's not actually touching. In fact, I'm going to zoom out a little bit just so we can kind of display this better. So I pressed zoom 3, and then I'm going to press enter. Okay. And that didn't really help us that much, but we can kind of see something's going on over here, something's going on here, something's going on that side. So I'm going to do zoom 6 again, just so we can see it. The next thing that I want to point out is those asymptotes are where we said that we cannot have x values because we said those two x values cause division by 0. Okay, so it's not just a coincidence that it's at 1 and -1. That's because those x values do not exist there. So that's why we say something is extraneous. If we look at this, nothing exists at those two values. Second thing I want us to notice, we said that our solutions for this particular problem were -2 and 5, and amazingly, we notice that's where it crosses the x-axis on our graph, which we've previously learned that, but it's nice to kind of see it once again. So connections we're seeing here, we're seeing where the x-intercepts are, and those correspond to our solutions. We're also seeing that no x values exist at -1 and 1. Those are the asymptotes. In fact, if I press the trace button, okay, remember this allows me to input any value I want. If I put in 1, for example, and press enter, this y value is blank, and it's because it doesn't exist there. So the final thing that we're going to do is write the domain of this function. And I know that the domain is all the x values that this exists. On my graph I have here, you can see that it shows the asymptotes as vertical lines. And I can see that our vertical lines here are at -1 and 1. So that means that our domain can be all numbers except for -1 and 1. So I'm going to write that in interval notation, which would be -infinity to -1, which really represents this portion of the graph, union, and that's really telling us the second part, and that would be from -1 to 1. And that is shown in this part that's up here that we can't really see in this particular picture. Union, we have a third portion, which is over here, and that is from 1 to infinity. So notice I have 3 different parts of my domain because I have 3 different parts of our graph. Also notice our unions are where the asymptotes are. So it's like I have an asymptote at -1, that's where our union is. I have an asymptote at 1, that is where our union is. So now let's look at number 2. Number 2, we have another equation here. The first thing I need to get is our LCD. And it appears as though our LCD is going to be 2x because those were the only 2 factors in our denominator. So now I'm going to multiply everything by 2x over 1. And I know I already said this, but just a reminder, The reason why I can multiply by 2x is because this is an equation. So as long as I distribute to everything, we're good. So when I multiply, I get 8x over x plus 10x over 2 equals negative 22x over x. And now we can see these x's cancel out and leave me with 8. I can reduce 10 over 2 and make that 5x. And my x's cancel out and I'm left with negative 22. And once again, this is the step that some of you guys might skip, and that is totally fine. This equation looks a lot easier because we have a linear equation. So I'm going to go ahead and subtract 30 and divide by 5, and I get x equals negative 6. Before I know that this is my correct answer, I need to double check, does it make my denominator 0? And looking, if I substituted it into either of these, it just gives me negative 6 as my denominator, so we're good. In fact, we probably want to think, what would make these denominators 0? And looking at those denominators, the only value that would give us a denominator of 0 would be 0. So now let's go ahead and graph this and see what our graph actually looks like. Now we're going to go ahead and graph this. So I'm already in y equals, and I'm going to do 4 divided by x plus 5 divided by 2 plus 11 divided by x, because I had to get my equation set equal to 0. And I'm going to press zoom 6 here. And we can see that it appears that it crosses at negative 6, and that was our answer. I can also see that it appears that it does not touch x equals 0, which would be the asymptote. So when we're figuring out our domain, we can see this would be one portion of our graph, and this would be the second portion of our graph. So here's a quick snapshot of what that graph looked like. So if I was writing this domain, we can see that the asymptote is here at x equals 0. So this first portion of our graph would be represented by negative infinity to 0. And the second portion of my graph would be represented by 0 to infinity. If we had to find the range, we would say negative infinity to infinity because we're seeing that all these y values are being found. Moving on to number 3, we can actually do this problem in 2 different ways, and I'm going to show you both methods. The first would be the same as we have been doing, where I need to figure out what is the LCD. I'm looking at this, both of these are already factored. So I'm thinking that the LCD is x minus 8, x plus 2. So I'm going to go ahead and multiply everything by x minus 8 times x plus 2. And what I'm going to see here is some stuff is definitely going to cancel out. So when I distribute to this first term, my x minus 8's cancel out, and I'm left with 2 times x plus 2. When I distribute to my other term, my x plus 2's cancel out, so I have 2 times x minus 8. When I distribute, I get 2x plus 4 equals 2x minus 16, and something really strange happens here. When I subtract 2x from both sides, I get 4 equals negative 16. This is not a true statement, so our solution is going to be no solution. And we're going to see what that looks like when we graph it and why it looks like no solution. So now I'm going to take us through the second way we could solve this particular problem. So what makes this problem unique is I have a fraction equal to a fraction. And when I have this, I can go ahead and cross multiply. So let me demonstrate how we would do that. So I'm going to multiply the numerator of one fraction times the denominator of the other fraction. So 2 times x plus 2. The other side is going to be the numerator of the other fraction times the other denominator, or 2 times x minus 8. Notice at this point, this is the same exact equation that we solved previously, just proving that it doesn't matter which method we tend to use. So Remember, we ended up getting no solution here. And now let's go ahead and figure out which values would have given us division by 0. And let me scroll down to that. And we would say 8 and -2. So I'm predicting that those are going to be where we see asymptotes when we go ahead and graph this. Graph number 3 here, I'm going to do 2 divided by, and then I need to quantify x minus 8, double parenthesis, minus 2 divided by, and then I need to quantify x plus 2. Quantify just means put it in parentheses. And then I'm going to press zoom 6 here to graph it. And some things that we notice, it looks like our asymptotes are at -2 and 8. Amazing how we already predicted that. The other thing that we notice is that this function appears to not actually touch the x-axis. So that is why we say that there's no solution, because there are no x-intercepts. So the final thing we need to do is write the domain. And once again, we can see that this domain is in 3 different parts. Our first part being from -infinity to -2. Our second part here being from -2 to 8. And our third part being from 8 to infinity. So that would be our domain. And here's our final problem. So I can tell that we cannot cross multiply this one because we have 3 different fractions. So I first need to figure out my LCD, which looks like it would be 3 times x plus 6, because those are the only factors that we see in there. So now I need to multiply everything by this LCD. So now we're going to distribute to each term. When I distribute to the first term, I'm foreseeing that the 3x and the 3x are going to cancel out. So I'm left with 2 times x plus 6. When I distribute to this second term here, I'm noticing these 3's are going to cancel out. So I'm left with plus 2 times x plus 6. Then lastly, when I distribute to this third term, I'm noticing that these x plus 6's are going to cancel out. So I'm left with 8 times 3x. So once again, my whole goal here is I want to eliminate my denominators so that we have no more fractions. Now I can go ahead and solve this. When I distribute this, I notice that we have a quadratic function. So I'm going to want to get everything over to the left side of the equation. And I end up getting 2x squared. 14x minus 24x is minus 10x plus 12 equals 0. I notice I can factor out a 2 of all of those terms. And then I need to think what factors of positive 6 would give me -5. And that would be -3 and -2. So I get x equals 3 and x equals 2. Looking at both of those answers, it appears that neither of them would cause division by 0, so those are our 2 solutions. In fact, looking at these, the values that it looks like it would cause division by 0 would be 0 and -6. So when we graph that, I'm thinking that's going to be our domain. I'm thinking that's going to be our asymptotes. In fact, because of this knowledge, I think we can already write our domain to be -infinity to -6, union -6 to 0, union 0 to infinity. And let's go ahead and look and see what that looks like when we actually graph. Final problem here. Okay, I cleared it out again and I'm doing 2 divided by 3x plus 2/3 minus 8 divided by x plus 6. So I'm going to press zoom 6. Okay, and as it's graphing here, I can definitely see we have an asymptote that looks like it's over at -6. It also looks like we have an asymptote at 0. Now, the other thing that's tough to see is what's going on in here. So I'm actually going to zoom in there just so we can have a better look at that. So I'm going to move the center of my graph to be between 2 and 3. And it's kind of tough for us to see this again. So I'm going to zoom in even more. And as it's thinking, okay, let's actually look at this. I know 2, and I typed, oh, that is not what I wanted to do. There we go. When I go to trace, let's go to zoom 6 again and kind of look at this. When I press trace and enter 2, it tells me it's at 0. And then if I keep going to the right, notice that it looks like it's close to 0, but it's actually underneath. Okay, it's not until we hit 3 that it actually hits 0 again, and then it goes above the y-axis. So that's why those are our 2 solutions on this particular problem. So hopefully you guys are feeling good on this. I want to stress once again on the homework and on the suggested problems and on the test. On the solving problems, all we need to do is solve. We don't need to graph them. This was just to further our understanding of what's actually happening here.